Hello everybody and welcome to part 3. In this part we're going to be giving our player a gun. We're going to give him a gun and he's going to be able to shoot some stuff, and we're going to give it a bit of recoil on the gun, a bit of kickback, make the gun follow the mouse around, and it's going to be very exciting. The beginning of this is going to be very straightforward, it's going to be pretty simple, but then a little bit later in we'll be learning about some new functions that we've not used before called length_x and length_y. So do keep an eye out for that and try and make sure you understand it when it does come up, because it will be very, very useful to you going forward if you decide to stick around and keep making video games, which I hope you do. Before any of that though, the first thing we need to do is just bring in a sprite for the weapon we're going to have. Okay, so I'm going to right click in sprites, hit create, we know how to do this by now. Hit import, I'm going to bring in S-gun, okay? I'm going to make sure from now on as well, all the resources, I said this before, but I didn't get around to it yet, but from now on, when this video goes out, all the resources will be in the description of the video for you to get, in case you want to follow along and use my exact resources so that you get everything line by line exactly how I've done it. You might learn a bit more if you're using your own assets, because you'll have to change some numbers around a little bit just to make everything work out perfectly. But it's up to you, you can do whatever you like. I'm going to name this sprite S-gun, okay? And then I'm going to position the origin for this gun. I'm not going to have it exactly in the middle, I'm going to have it kind of between the two hands. I know it's hard to see that it's zoomed in, but the idea here is there's like a hand around there and a hand on there, which looks a little clearer when it's actually on the player sprite. But yeah, about 10 by 4, that's where I'm going to have that there, just by dragging that crosshair to the right place. Okay, so our next step, as usual, is to add an object for the sprite we've just created, right? So I'm going to right click in objects, hit create, and call it O-gun, just the same as the sprite, just the same as the pattern we've been using for everything else. I'm going to set the sprite to match S-gun for O-gun, and then what I'm going to do is I'm going to place it in the room, and I'm going to add it to its own layer because we want to make sure it always shows up in front of the player. So I'm going to create a new layer called gun, and I'm going to drag a new instances layer, for that matter, it's the one with the little circles. I'm just going to drag O-gun into the room while we've got that layer selected, okay? And that just guarantees that we get our depth ordering correct. Because, I mean, I could put this on the same layer as the player, and like a lot of the time it would probably work out and you could probably get away with it, but you can't rely on two objects on the same layer always being correctly shown, okay? If you want to, you need to, if you want it to be consistent, and if it matters whether or not one object is drawn in front of another, you have to have them on separate layers, okay? It's really is the best practice. Now, the reason that I've made the gun as a separate object and we've got our kind of player with no arms running around is because I kind of want the gun to be able to move and act freely of the player, okay? So even though it's going to be kind of locked to the player in terms of position while the player is walking around, obviously it doesn't want to actually float like this detached from him. I want to be able to point it wherever the mouse is, and maybe give it a bit of recoil and stuff when we're shooting and things like that. And that stuff's just a bit easier to accomplish and easier to think about when you're working with it as a separate object, okay? It's not the only way you could do those things, but it is probably one of the simplest. So at the moment, if we were to run the game, we'd just get our player would run around and have all the stuff we had from the previous episode, but the gun would just hover there because we haven't done anything with it, right? So what we're going to do is make the gun follow the player around, and you'll see as I do this, one of the other reasons for making it a separate object is it lets me do some fun stuff. So I'm going to double click on gun just to bring us to our gun object. Here I'm going to press F12, gives a bit of space, hit add event, and then I'm going to add the begin step event, okay? Now we've used the step event before, which is an event that just happens every single frame of the game, right? And the begin step works exactly the same way, only begin steps will happen before any steps happen, okay? So if you need something that needs to happen every frame but needs to happen before any other object's step event, you can do that using a begin step, and you can do the opposite by using the end step and do something after every other step event has taken place that frame, okay? Now, I'll explain why we're using this particular step event in a moment. The code I'm going to write in here is simply x equals oplayer.x, semicolon, and y equals oplayer.y, semicolon, okay? Now I'm going to run the game and kind of demonstrate what this does. So you'll notice the gun is kind of moved and it's kind of on our head at the moment, which is a problem that we will fix. But as I move around, you might notice something. Now the code I've written there, and you probably worked it out, is it's pretty simple. Is just setting our X and Y coordinate to match whatever our player's is. But if you noticed, it doesn't quite keep up. You'll notice there's a slight bit of lag. If you look very closely between where the player is and where the gun is. The gun, it appears to be, and because it is actually 1 frame behind the player until you stand still, and then it gets a frame to catch up, you know? But while you're moving around, it's always 1 frame behind, and that's because we're updating it in the begin step event. And doing this allows you to kind of create a very simple feeling of weight to the weapon, okay? It feels like he's actually carrying it around, like it's got a bit of force to it because he's got to kind of lug it around. It's not too obvious at the moment because he's kind of carrying it on his face, so we'll fix that now. The easy way to fix that is to just add a number to the Y coordinate. Let's just bring it down a bit, okay? And just manipulate this number until you get it in the right spot. Now, you might be thinking, well, why not just change the origin point for that, okay? If we look just up at our gun over here, we can see our origin is in between our 2 hands here. If I were to just raise the origin point up, that would achieve the same thing as doing this. But we want to be able to rotate this gun around and do other things based on its origin later that aren't going to work very well if our origin is up here somewhere, right? We want to keep it between these 2 hands because we want that to kind of be the center point for the gun in terms of like rotation and like where it's aiming at and so on. But let's just see the effect here. And say +10 will work for me and it'll work for you if you're using my assets. You might need to play with the numbers a little bit yourself to get your own asset working. But you can see now he's carrying this gun around, and because of that just little bit of lag added to the gun, he just has a tiny bit of weight, tiny sensation of kind of like weight or force kind of on this gun, like it's like he's really holding it. And it's sort of like a dynamic sort of addition to your animation in a way, and just helps the sprite feel a little bit more alive. Up to you, maybe you don't like the effect, but I think it helps kind of make him feel a little bit more real. Okay, so the next thing we're going to do is, at the moment the gun just sort of always faces to the right like this, and we're going to make it face towards wherever our mouse is. So if I close the game now and just still in this begin step event, we'll keep doing stuff in the begin step event for now. You might want to swap to the main step event if you want. It doesn't really make too much of a difference. It's just for subtle things like that now and again. So, I mean, it's up to you which event you want to put this in, but just for clarity, I'm just going to keep most of the stuff in the begin step event for the sake of this tutorial. Okay, so what I'm going to write in here is image_angle, and you can see that turns green. It's another property of the object, okay, just like our X and Y and our other things that we've done with our player object before. The image angle controls the angle at which the image is drawn to the screen, or the image of this object will be drawn. Okay, and by changing it, we can rotate the gun. And we want to rotate it based on where our mouse is on the screen, okay? So I'm going to type point direction, okay? This is an easy, you can see it turn yellow. It's a simple function that you give one coordinate and another coordinate, and it works out what the angle is between those 2 coordinates, okay? So I'm going to put in our current coordinate, which is xy, and the coordinate that we want to work out the angle to, which is the mouse coordinate. And we can find that at any point in the game, in any script, anywhere. If you ever need the mouse coordinate, all you need to type in is mouse_x and mouse_y, and that will return the current mouse position in the room of your game, at the current coordinate of your mouse in that room. Okay, and because we're giving it those 2 coordinates, that's all we need. We can close the bracket now, add the semicolon, and now that's going to make sure our gun points towards our mouse. Okay, so if I run the game there, you can see it starts to spin around, and it points where our mouse is pointing. Okay, you notice there's a bit of an issue that it flips upside down when we're facing to the left, like the hands appear to be on top. Which I don't know, some of you might like that kind of approach for like looking like you're kind of holding it over your shoulder type thing. We will look into sort of fixing that and making it sort of standardized later, and you can play with it yourself and get the exact look you want for your weapon. But we'll look into that much later. We've got other things to do first. The next thing we're going to do actually is change some of these controls around, because at the moment you might, especially if you're following along, you'll find this a bit awkward to control with our current controls. I've got the arrow keys to move and space to jump, which is fine when you've got both hands on the keyboard, but if I want to aim with my mouse, I kind of need a hand for the mouse. So having to stretch my hand on my keyboard, at least from the arrow keys to the space bar, is it's pretty hard. I'm doing it right now, but it's pretty difficult. So I'm going to just swap the controls to kind of a WSAD type thing, very typical kind of gamey controls, which I'll show you a bit about how to use arbitrary keyboard buttons as well as just the arrow keys and spacebar and that sort of thing. So let's come into our player object. Okay, just open this up. I'm going to maximize this because there's quite a lot of code, so I won't be able to kind of see it all. At the top here where we get key left, key right, and key jump, you can see at the moment we've got keyboard check, VK left, and VK right. What I'm going to do, actually, instead of just changing these to be something else, I'm going to add 2 line symbols like this, okay? For me, that's pressing shift and the backslash key on my keyboard. It might be somewhere else on your keyboard, but that's where it is for me. But you can also type the word OR, and that turns yellow, and it does the same thing. I'm just going to use the 2 symbols because that's what I'm used to, basically. And as you might have guessed from what I just typed, it means OR. So after those 2 symbols, I'm going to write another keyboard check. And I'm going to put in, instead of VK left or anything like that, I'm going to write the word ORD, open bracket, open quotation mark, and we're going left, so we want the A key, and close those 2 pairs of brackets, and end with a semicolon. So what this has done here is I'm setting key left, that variable, to equal keyboard left, VK left, keyboard check, VK left, just as before, or keyboard check, ORD A. So what OR is going to do is it kind of does a binary thing, like if this is 0, then key left would be 0, right? And if keyboard check ORD A is also 0, then key left will also be 0. But if either one of these is 1, then key left will be 1, okay? So it'll either take this value if it's true, or this value if it's true. If both of them are false, then it comes back false, and this will be 0, okay? But if either one of them are 1, key left will get set to 1, and that's how OR works. And you can do this multiple times. I could keep adding ORs on the end like that, and if any one of the conditions is true, we'll end up putting a 1 into key left. And what this means is we can now use the left arrow key or the A key. We can use either one in order to move left. So I'm just going to copy this section here and paste it on the end of this line here. I'm going to change the A there to D. And this ORD command, as you've probably guessed, is just a function that returns the exact key code. Like so all the keyboard, all the keys on your keyboard have like a number code associated with which sort of button, which position they are on the keyboard. And what this does is it takes the letter you want and translates it into that keyboard code, which we can then use in keyboard check to get that particular key. It's exactly what VK left is actually doing. It's just providing the code on the keyboard for the left arrow key. It just happens to be a built-in constant, whereas for arbitrary letters we need to work it out by using ORD, okay, and just putting in the capital letter that you want to use, okay. So if I run that now, we'll find, I mean, you won't see anything different on the screen, but if you trust me, it's much easier to control now. I can use the A and D keys, and I can leave the space bar the same because I can reach that very easily with one hand. Use whatever controls you like, but there's a way of being able to use multiple different control schemes for different people. At some point in the future we might look at rebinding keys, although that'll probably be a separate tutorial from this series. And we also might look into gamepad controls a bit later on as well. But for now, we'll leave these as our current kind of controls. So we have our gun now, and it follows the mouse cursor around. The next thing we want to do is actually add our bullet. Okay, we want to add something the gun can actually shoot. So I'm going to right click in sprites again, hit create, import, and I'm going to bring in sbullets underscore strip2. By bringing it in as strip2, it splits it into the 2 frames I want. Now you might be wondering why we've got these 2 different frames. We've got a big circle and then something that looks a bit more like a bullet. What I'm actually going to do is a pretty simple trick. I'm just going to call this sbullet. A pretty simple trick for creating a muzzle flash on a gun, okay, or any like a weapon that you can shoot, right? Because you've all seen that in games. You shoot a gun, there's a big flash at the start of the gun, kind of creates a good piece of visual feedback. And a very easy way to do that is to just make the first frame of your bullet a big white circle, a thing that looks like a big muzzle flash. And then all we need to do is when the bullet finishes its animation, we just tell it not to animate anymore, and then it stays on this frame. So then the bullet just travels like that. Very, very simple way of creating a muzzle flash, which you'll see in effect in a moment if that didn't make sense to you. So where we've got speed at the top here, do make sure you set this to 60. Okay, because that's the frame rate of our current game. At least I think it is. Let me check. Yep, 60 frames a second. We did do that. So you need to make sure that this is 60 because we only want to show this for 1 frame. Okay, we don't want to show it for multiple frames, otherwise the muzzle flash will appear to sort of travel with the bullet. We just want to kind of show it at the start of the sort of edge of the barrel of the gun, just as we're firing. Okay, which is where the bullet's kind of going to come from. Alright, so that's our bullet sprite, and now let's move on to making our bullet object. So right click in objects now, hit create, let's call this bullet, set our sprite to be sbullet, and then what we want to do is actually create another layer in our room. So let's come back to our room editor, because again we want to keep making sure we have a fine control over what's shown over what and what's shown under what. So let's create another bullet layer, let's create another instance layer, and we're going to call it bullet. Or we'll call it bullets, I guess, because there's going to be more than one of them, probably quite a lot of the time. And we're going to make sure that that's just above our gun and above our player, okay, so it just shows up above everything. So we get a nice big circle on the end of that when we have a muzzle flash, so it doesn't go under the gun and so on, okay. Once we don't have to place anything in the room because obviously we are going to create our bullets dynamically, okay? So with the others, we've just placed them in the room. That's one way to make an object in your game, but you can create them dynamically at runtime, which is what we're going to do next. Well, actually, okay, we're going to do a few things to the bullet object first, but then we're going to do that, okay? First of all, though, we want to open up our bullet object, and we've got a few things we want to set up in here before we do anything else. There's not a whole lot we need to do to the bullet, we just need to set up some things just to save us a bit of time doing it later, just to make sure the bullet behaves how we want it to. Most of the stuff we want to do with the bullet is going to happen in the gun object, but we do need to set up a couple of little things here. The first thing I'm going to do is go to add event, and I'm going to add the other animation end event, okay, so in other animation end. So this event happens, as you might have guessed, when the animation comes to an end. So at the moment, by default, we've got our bullet and it'll animate at 60 FPS and then it'll finish, and then we can do something when that animation ends. And what we want to do is make sure the animation doesn't happen again. We can simply do that by typing image speed equals 0, okay, and that will multiply our current animation speed of 60 frames a second by 0, leaving us with a speed of 0. So it won't animate anymore. And then what we want to do, though, because our animation will have finished, it will have looped back to our first frame, which is the muzzle flash. But that's not what we want. We want to fix our image on the first frame of our image, not the 0th frame, okay? We want on frame 1. So it's the second frame, but it's frame 1. I know it's kind of confusing. I think I went over this before, but this is frame 0, and this is frame 1. So we want to leave it on frame 1. We can do that just by typing image underscore index equals 1. Okay? Just some similar stuff to what we did with the player sprite and animation, just changing those values. And that'll make sure that we are on this circle frame for 1 frame of our game at 60 frames a second. So we just get a very, very quick flash, and then it changes to this bullet sprite for the rest of its life. Okay? The next thing we want to do is make sure that when this bullet collides with a wall, it gets destroyed. Now, the simplest way to do this would be to go to add event, add the collision event with a wall, and just blow up the bullet. But we're going to do it a slightly more complex way, just to kind of make things look a little nicer. What I'm actually going to do is use the post draw event. So you go to draw, you see all these various different draw events. We won't be using these for a little bit of time yet, for the most part for their intended function anyway, but we're going to use the post draw function. The reason I'm using the post draw function is it's a very similar event to the step event, and similar to the begin step event that sort of changed the order of when things happen. This does something very similar. The draw events are quite like the step event in that they happen every single frame of the game, but they typically have to do with rendering and drawing stuff to the screen. In your main draw event, that's where your image is actually, where a sprite is actually drawn to the screen, and that's where everything involving drawing the sprite and animating it is actually done by the game engine, okay? By doing something in post-draw, that's an event that happens for every object in the game, every frame of the game, so just like the step event, but it happens after all of our drawing and all of our rendering is finished, okay? What I'm going to do is I'm going to type in here, if place meeting x, y, o wall, okay? As you'll remember from our collision stuff in our player, that's checking to see whether or not there's a collision between this object at these coordinates with this particular object type, and if there is, we do whatever comes next. And I'm not going to open curly brackets for this, I'm just going to type one simple line, instance destroy, and just get rid of it. Now you might be thinking, well, why didn't I just do this in the step event? Why do I need to make sure this happens after everything's been drawn? Well, by doing this, it makes sure that we draw our bullet before we actually get rid of it, okay? Otherwise, you're not actually getting rid of the bullet on... you'll see the bullet disappear before it actually hits its target, which you might want. You might want it to look like that. It's a perfectly normal thing to do. It's like that in a lot of different games. But by doing this, it means if we shoot directly down at the floor, you'll get to see the muzzle flash still. You'll still see like that first frame of animation. Because it'll get drawn before we actually find the collision with the floor and then get rid of it, okay? So we get to see exactly where the bullet collided by doing this, which just makes things a little bit clearer, okay? You might want to be careful with always doing this sort of stuff post-draw. You usually want to use the draw events just to do drawing stuff rather than logic, but this is just kind of one exception that kind of makes things a little bit simpler. It's just a simple place to put this and it doesn't really cost you anything. Okay, but we need to actually make it so our bullet shoots, so we can actually see the result of any of this. But I'll come back to this so that you can kind of see what's going on with this, and I'll show you what happens if you were to just use the step event. So don't worry too much if my explanation of that didn't make too much sense yet. So sorry about that. There was a lot of explanation for just like 3 lines of code. But let's come back to our gun object now. Let's just come back to here and our begin step. Again, I'm just going to kind of do everything in the gun in the begin step because why not, really? I could move this stuff to the step event, but I don't really need to, so I'm not going to yet, okay? What I'm going to do is going to check to see if we're pressing the mouse button, and if we are, we're going to shoot. Actually, though, before I do that, I need to add the create event, and what I need to do is add a variable in here called firing delay equals 0. Okay, ooh, I accidentally pasted a bit of code in there. Firing delay equals 0, you see that turns blue. We've created another variable, we've done this before, okay, we've just created a word that represents a number. That word, firing delay, represents the number 0, and we're going to use that variable to make it so that we don't fire our gun every single frame that the mouse button is held down, okay, and we just fire it like every few frames while it's held down. Okay, so I'm going to type if mouse check button MB left, okay, I'm going to type 2 ampersand symbols, or you can also write and if you want. This is very similar to or, so this allows us to check, I may have covered this before, I'm not sure, but this allows us to check whether 2 conditions are true rather than only checking 1 condition. It's different to OR in that it needs both conditions to be the same, so they can either both be 0, or they can both be 1, or they can both be false, or they can both be true. They have to match, though. They have to be the same thing in order for whatever we put after the if statement to happen, okay? I'm going to use the two ampersand symbols because that's what I'm familiar with. Again, you can just use and if you want in place. But what I'm going to put with this and is another condition, which is firing delay less than 0. Okay, and I'm going to open a couple of squiggly brackets here, and this is where we're going to put our stuff to actually shoot. But just above this statement, I am going to write firing delay equals firing delay minus 1. Okay, so what that's going to do is it's just going to take this variable, reduce it by 1 every single frame, so eventually it'll go under 0. And what we'll do every time we fire a bullet is we'll set firing delay to be like 5. Okay, meaning that the next time we'll be able to shoot will be 5 frames after our last bullet was created. Okay, and that just kind of gives us a 5-frame delay in between each shot. So we'll do that right here. We'll just type firing delay equals 5. Okay, so that only happens when we actually make the shot, which we can only do when it's below 0, and then it reduces by 1 every single frame. Okay, so now I'm going to introduce another new function here. I'm going to type with. Okay, what with does as a function is, okay, you provide the name of another instance or another object. So I could do like player or something, for example, which is not what we're going to do, but for example, and then open another pair of squiggly brackets. And what this would do is, instead of applying whatever code we write in here to our gun object, it would apply it to whatever object or whatever instance of an object we place inside the brackets. So if I did anything in here like x equals x plus 5 or something, that wouldn't happen to the gun, even though we're in the gun's begin step. It would happen to the player. Okay, it's very, very useful, the with statement, very, very useful. What I'm going to put in here is actually another function which creates a new instance. So I'm going to type instance underscore create underscore layer. Okay, this creates an instance of another object. You might have heard me say before, I'm not sure if I covered it in this specific series, but your objects are like the blueprints of your code. Okay, it's easy to sort of fall into the mistake of thinking that the things running around inside your game are your objects, but they're not. They're actually instances of your objects. They're copies, if you will, of the blueprint that you've established in the game. So our player in the actual game world is an instance of player. And so we can create new we can create new instances in the game of other objects by using commands like instance underscore create underscore layer. And I'm going to open this, and I'm going to give it the coordinates where we want to make the instance, which is wherever our gun is, so x and y. And we want to give it the layer that we want to create the object on, and that's going to be bullets. Okay, make sure you add the quotation marks there, that's quite important. And then the name of the object type that we're going to create. Okay, and we want to create an bullet. So after doing all of that, why on earth have I stuck this inside a with statement? Well, by putting this in a with statement, what instance create layer actually does, and you don't need it to do this every time, but when you run this function, it actually produces a result. So I could type like the name of a variable, like bullet equal instance create layer or something like that, right? And that function would actually put a value inside the word bullet. You don't have to do it like that, you can just do the function on its own, but by doing it in this sort of way, it puts a value into this with statement, and what that value is the instance ID of the instance you've just created. So we're going to make a bullet, and we get its ID, which allows us to then do stuff with it using the with statement. Okay, it's kind of a 2-for-1. It allows us to create the object and then provide its ID to the with statement to then do stuff immediately to that instance. Okay, what we want to do to that instance is we want to make it move. We're going to give it a speed. So we're going to type speed, and you can see that turns green, that's a built-in value, equals 25 pixels a frame. Now you might be wondering, well, if speed exists and you can just give something a speed as a property, why on earth did we do all this weird movement stuff in the player? Well, speed, once you set it, is fixed, and then that object will just keep moving at that speed until you change the speed. It's a lot more manageable when you're doing complex movement, like with our player, like moving left and right and jumping and all that kind of stuff, to manage everything manually by like controlling our X and Y coordinates. But if our bullet is really simple, like it's just an object that we want to just fly off in a direction, and we don't need it to really do anything complex or respond to input in any way or really do anything complex. So I can just set a speed and it will just move at that speed, and then I also can just give it a direction to move at that speed in, and it'll just do its own thing and basically kind of manage itself, which makes things a lot easier for us. So I'm also going to type direction, as I just said, and that turns green, represents the direction to actually apply our speed in. I'm going to type other dot image angle. Now the word other has a lot of different uses, and in this particular context, inside of a with statement, if you use the word other, which turns red, and then a dot, you're referring to the property of the original object. So you're referring to gun, because you remember inside with, anything we do here is applied to this bullet we're creating, okay, and not to the gun object. But we can refer back to things from the gun object by using other dot, okay, and then by typing image angle, we're getting the image angle of the gun, which is what we set here. Okay, so this is what's going to make our bullet move at the same direction as our gun. Okay, make sure we actually shoot the right way. But that only affects the direction of movement. It doesn't actually affect the actual angle the bullet is going to be drawn at. Okay, we need to change that as well, which is our image angle, right? So I'm going to type image underscore angle equals direction. Since we just set our direction correctly, we can just then copy our direction. I could have written other dot image angle again, but you'll see a little bit later why I didn't do that. It'll just help us out a bit later. Okay, that's really all there is to it in terms of just shooting, and we've already got our bullets set up to collide with walls and stuff like that. So I should now, hopefully I've not forgotten anything, I can run the game, and I can move around. We've got our gun, aims where we want it to, and if I click, you can see we actually shoot, and you can see we've got that muzzle flash at the start, a little white circle just appears right on the peak of the gun. Luckily, the numbers I've used, the speed that I've used and everything, means that the muzzle, like, it's actually just worked out perfectly, and the muzzle flash is right at the edge of that barrel, which is exactly what we want. But you might remember the origin of our gun, it's hard to highlight because it moves around, is like between our two hands, and that's actually where the bullet is when it's being created. But because we set its speed right away, it moves 25 pixels before it even gets drawn for the first time. Okay, so that means the first time we actually see it on screen, it's actually just happened to move the right amount. Now that's not the best way to manage it. It just happened to work out very well in this scenario. You might find with your own assets, it doesn't really work out that way. But when we get to a little bit later in the video, I know this one's getting quite long, sorry about that, but when we get to adding the recoil to the gun, you'll see using length to X and length to Y how you would be able to manipulate the position of that bullet if you needed to. Okay, so we've got our gun, we've got our bullet, and I guess in a way we could end this tutorial here. We've got mostly everything. But what I am going to do is add just a couple of little nice touches here or there that will just give this a little bit of polish, make it feel a little bit better, a little bit sexier, okay? First thing I'm actually going to do is I'm going to kind of randomize the direction we shoot our bullets in just a little bit, just to kind of give it a bit more feeling of being kind of a gun, you know, a big machine gun that's a bit unwieldy and hard to aim, right? So instead of ending that line there with direction equals other dot image angle, I'm going to type other dot image angle plus random underscore range. Now this yellow function, what it does is it takes two values and it returns a value in between them somewhere at random, including the values you give. So I'm going to use -3 and 3. Okay, so this function here is going to equal a number between -3 and 3, inclusive of those numbers. Okay, it could be anything from -2, it could be 1, it could be 3, it could be -1, etc. Okay, and what that does is we're just going to add that value onto our image angle, just to kind of offset the direction a little bit randomly with each bullet we fire. And now if I run the game and I shoot, and you see without moving the mouse, our bullets have got a bit of a random spread through them. It's subtle, but it is there, and it just kind of gives us a bit more of a kind of a randomized machine gun effect. The next thing, and this is kind of the big one for me, is like firing this gun feels a bit weightless at the moment. I mean, I know we added this kind of feeling when you're carrying it around. When you're carrying it and not shooting, it feels kind of nice and weighty, but it's kind of hard to believe the shooting at the moment because there's no recoil. Like the gun just sort of hovers there and the bullets just sort of come out like magic. And it looks like these bullets don't really have much weight to them. It looks like they must be pretty light, not very damaging or anything like that, because like they don't seem to weigh anything. It might as well just be like a little BB gun or something, right? So let's give it a bit more weight. Let's make it feel a bit more, give it a bit more oomph. And we can do that just by giving the gun a bit of a kickback, okay? And we'll just make the gun sort of jump back as if it's kind of a bit hard to control for the person shooting it. So how on earth do we do any of this? Well, the first thing I'm going to do is come into our create event. I'm going to add a new variable called recoil. Okay, I'm going to set that to 0. And what recoil is going to do, we're going to set it to say 4 whenever we shoot. Okay, whenever a new bullet is made, I'm going to set it to a little number, and that's going to represent how far we want to move our gun backwards. And then every single frame, we're going to slowly decrease it. So while we're not firing, it'll just return to default position, because when recoil eventually hits 0 again, our gun won't be moving by any amount. Okay, so every time we shoot goes to 4 and then slowly decreases. Well, it'll be quite quick really, but every single frame decreases by 1 and gets back to 0. Okay, so we get a kind of juddering effect while we're shooting, gives us a bit of a kickback. So how do we do that? Well, the first thing we're going to do is make it so that when we fire, we set recoil to 4. So in here, I'm going to type recoil equals 4. Make sure you do this where we set our firing delay, because we're doing it in very much the same way. Don't set it in the with area, because that stuff affects the bullet. We want to affect the gun. So make sure you do that there. And just up here as well, when we do our firing delay stuff, when we reduce that by 1, I'm going to basically decrease our recoil by 1 every single frame, okay? Recoil equals max 0, recoil minus 1. Now, you might be thinking, well, you didn't do the same thing there. You've used this weird thing called max. What does that do? Well, what max does is it returns the biggest of the values that you give it. You can give it any number of values, just separated by a comma. I've given it 2, I've given it the number 0, and I've also given it recoil minus 1, okay? So as you can imagine, if recoil minus 1 happens to be bigger than 0, we return that, and we've done exactly the same things we've done up here, just reduced the value by 1. But say that recoil is 0, when we do recoil minus 1, that'll give us minus 1, and 0 is bigger than minus 1, therefore 0 will be returned. All it does effectively is make sure we don't go below 0, okay? It kind of caps us. So while recoil is 4 or 3 or 2 or 1, it'll reduce by 1, but when it hits 0, it'll just stay at 0 until we fire again and it gets set back to 4. Okay, very, very simple. So we've got the value doing exactly what we want. Now we just need to apply it to our weapon. What we're going to do, this might seem kind of impossible if you think about it at the moment, because we've got our X coordinate and we've got our Y coordinate, right? And we can manipulate those in order to move ourselves around. But how do we move just in a given direction? Well, we're going to use what's called length de x, okay, this function. I mean, I'm not going to use it exactly like this, how I've typed it, but this is the function we're going to use. Let me see if I can explain now, hopefully with some diagrams and stuff, how this works. Okay, so we have an X and a Y coordinate where our instance is, and we want to move in a particular direction. Now, we don't know, the problem here is that we don't know the exact X and Y that we want to end up in. If we did, we could just set our X and Y to be that, right? But we can't do that because we don't know what those are. We only know the angle that we want to move at and the amount of pixels vaguely in that direction, okay, that we want to move. we can't just use that number of pixels in our x and y, because we might be moving a different amount in x to the amount we're moving in y, right? We'd only be able to move at 45-degree increments that way, okay? But we want to be able to move anywhere 360 degrees in any direction at any kind of length. Now, if you know a bit of trigonometry, you can actually work this stuff out very easily without using this function. But what length do x and what length do y do is, if you imagine that position that we have, and you know the angle that we want to move, and we know the distance that we want to move, what length do x will do is, given that direction and given that length, it will return the number of pixels you have to move in the x-axis to reach that position. And similarly, length to x returns the number of pixels you need to move in the y-axis to reach that position. And once you combine those two results together, boom, you have the coordinate that you want to move to. Okay. Hopefully that explanation made sense. Hopefully my diagrams kind of made it a bit clear. It's very, very, very useful to understand that. It allows you to move any instance in basically any direction by any arbitrary amount very, very, very easily if you can understand that. So that's what we're going to do now. So we're going to type x equals x minus length to x, open bracket, and then you can see at the bottom we need to provide the length and the direction, just as I said. Given a given angle and a given amount that we want to move, we can work out that x component. Okay, so the length, the distance that we want to move is recoil. Okay, it's when this value is 4 when we shoot and it decreases over time towards 0. We want to move by recoil amount. And the direction is image angle. Now you might be thinking, wait, don't we want to move to the opposite of our image angle? The image angle is the direction the gun is currently facing. Don't we want to move the opposite of that? And yes, we do, which is why we're subtracting this value. Okay, we're subtracting it so that we move in the opposite direction. Just a cheap way of doing that. I could have added the value and used image angle plus 180, but I think this looks a bit cleaner than doing that. And that's all there is to that. I'm just going to copy and paste that line and change my x's to y's. Simple as that. Just change the x's to y's in that line, and then we get our y component and we do the exact same thing. Okay, so let me run the game now. Hopefully I haven't forgotten anything again. If I run around and I start shooting, you can see now the gun has a proper kickback. You can see it just jutters back with every shot and then just returns to the default position when we actually stop shooting. Okay, just kind of gives that gun a bit of weight, a bit more oomph. It just feels a bit more real, like he's actually holding a powerful weapon, okay, there when he's shooting. One thing to point out that I kind of forgot about earlier is you can see when we shoot down, we still get our muzzle flash appearing, but we don't see any bullets. That's because we actually set that bullet to only get destroyed in the post-draw event rather than in the step event or in a collision event, okay? If we destroyed it in a collision event or in a step event, we would never see the muzzle flash, and we just get the sort of juttering thing, looking like we're just shaking the gun when we're shooting at the floor, okay? And we wouldn't get kind of the impression that we're just sort of shooting the floor a bit, okay? I just prefer to do it that way, and we can also see the bullets collect exactly where they get destroyed on contact with the wall, rather than if we did it a different way, they would sort of disappear instantly before they hit the wall, so they'd probably sort of be disappearing kind of around this sort of area before the frame where they actually make their collision. So we've covered a lot of stuff in this part. My voice is starting to strain, so we're going to cover one more thing just to kind of round off the stuff to do with the gun and the bullet. I think we've done a lot of cool work. I think it looks quite polished and good. So hopefully it was worth this episode probably being really, really long. The last thing we're going to do is make it so that our gun faces kind of the right direction. You'll notice at the moment when we sort of turn our gun and we point it to the left, our hands are on top of the gun, which looks kind of silly to me. So I'm going to show you how you can kind of manipulate that, and you might want to change it so it fits your own personal taste, but this is how I'm going to do it. So I'm going to type if, just at the bottom of the gun here, image underscore angle is greater than 90. And, okay, and you remember from earlier, we're going to check another condition, and if they're both true, or they're both, oh no, just if they're both true, sorry, if they both come back true, then we're going to do the thing. So if image angle is greater than 90 and if image angle is less than 270. And so I've explained to you previously how when you set up a sprite, you kind of want to make it face the right initially, okay, facing towards the right, especially when you want to do any angle stuff with it. And that's because image angle of 0 typically represents facing to the right, okay? And an image angle of 90 is facing straight up. An image angle of 180 is facing, well, 180 degrees the other way, facing left. 270 is down, and 360 or 0 again is facing to the right, okay? So because that's how GameMaker handles degrees and angles and direction, that's why it makes sense to just keep all your sprites consistent and have them all initially drawn facing to the right before you kind of manipulate their angles and stuff, okay? So here, and I'll bring up that image again, like if image angle is greater than 90 and it's less than 270, that means we're facing somewhere to the left, okay? Even if it's only by 1 degree, we're facing to the left. And if that's not true, then we're facing to the right, okay? So if we're facing to the left, what I'm going to do is I'm going to type image y scale, so our vertical scaling, equals minus 1, okay? And that's going to flip our gun upside down. But as you remember, because when we rotate it around its origin, it is upside down when it faces to the left. So by flipping it upside down, we get it right way up. Okay? And then else, so if we're not facing to the left, if we're not facing to the left, then we know that we're facing to the right, right? So if we're facing to the right, we set our image y scale to equal 1. Okay, so we set it back, which is what its default is. So if I run the game now, just off of that, you can see so at the moment, we can see our gun here facing to the right, just looks as it always did, but if I go over the top, you can see it flips around, and now it still looks like we've got our hands underneath it, and we're holding it properly, which looks kind of cool. Looks like he's kind of just flipping it around like that. I like it that way. You might find your own way that you kind of prefer to do it, but there's some simple logic to help you learn how to kind of manipulate how it looks when you're facing each particular direction. Okay, that's all there is for this part. Thank you very, very much for watching. Hope you got a lot out of it. Sorry it was probably quite long, had quite a lot of new stuff going on in it, but I like to think it was jam-packed with quality learning material. So yeah, I hope you guys are enjoying this, and I'll see you guys on part 4, which will be not next Friday, but the Friday afterwards. So I'll see you guys then. Thank you once again to all of my Patreon supporters who make this work possible. Special thanks in particular to Inner Mule, Giles Montgomery, Roxom, Harold Guidry, Dan, Jason McMillan, Angel Rodriguez, and Owen Morgan. Thank you ever so much for your continued support. I'll see you guys in 2 weeks for the Platformer series, and next Friday for, I don't know, my Patreon supporters are currently voting on what that video is going to be, so we'll see what it is next week. Can't wait. See you guys then. Thanks for watching.